Hi, my name is Cynthia, and today I'm going to walk you through our experiment where we determine the charge of two balloons. So, to introduce it, we mainly researched the question when experimenting with two identically charged balloons, what is the relationship between distance and the charge of the balloons? And this main goal was to determine how changing the distance actually impacted the charge and the electric potential. We mainly found that as the distance between the two balloons increases, so will the electric potential as well as the force between the two balloons. Overall, in the one trial that we did of our experiment, where we found the charges at a distance of r equals zero point 0.1 meters, we found the charge to be equal to 763.82 coulombs. So let's talk a little bit about the variables. So we determined the independent ones to be the charge and the masses of the balloons, and the dependent ones to be the distance and the angle between the two balloons. To our right, we have a couple of defined variables as well as some equations we used in our calculations. Let's talk a little bit about experimental design and models. So we blew up two balloons to be equal size and we weighed them to be zero point 0.1 grams. We tied a string to each of them and then charged them an equal number of times with the same material. We then hung the balloons from a single point and then measured the distance as well as the angle produced. Here we have some models. So we have our force body diagrams to our left here. They're pretty similar. And we have some uh, bar charts to our right, where we determine that as the balloons are farther apart, the kinetic energy will be higher and the electric potential will be lower, and vice versa for if they're close together. Below, we also have a system schema. Here we actually have our experimental setup. So we have our two balloons attached to our string, and here you see our actual tracker screenshot here. And we really use this to determine that those distances and angles were as precise as possible. Here we have our analysis and our calculations. So by finding the angle between the balloon and the string, we were able to determine the electric force that one balloon exerts on one another to be 0.5665 newtons. We then use Coulomb's law and solve for Q2, which represents the quantity of charge on balloon 2. And since the balloons were weighted to be of equal mass and we rub the balloons in an equal number of times with the material, we can determine that Q1 is approximately equal to Q2. So let's talk a little bit about the physics or the scientific reasoning behind this. So the force between the balloons is dependent on three variables, the charges of both balloons and the distance between the two. So when the balloons are rubbed with a material, they're going to gain a negative charge because those electrons are more attracted to the balloon than the material. So since the negative charges are the same, they're going to repel each other, and then that string that the balloons are attached to are going to form an angle. And then using our known masses, we can determine the force of gravity, and then that value is actually equal to the vertical component of the tension force. So we can also determine the horizontal component, and then that is actually equal to the electrostatic force between the balloons. And then we can also use Coulomb's law to solve for both of those charges. And then since the balloons share the same charge, we can rearrange it to equal the charge and determine the charge of both balloons. So how did we minimize error in our experiment? So only one person actually performed the experiment, and the same material was rubbed against the balloons to charge them. This kind of reduced the human error a little bit. We also measured the angle and the distance between the balloons, as well as the mass of the balloons multiple times to ensure accuracy. Also, there were multiple control variables throughout our experiment. So, some additional scientific reasoning. So, we performed one trial in which we determined the charge of the two balloons to be 793.82 coulombs when r equals zero point 0.1 meters. And here is our actual equation that we used in the middle here. So, after measuring the angle formed along with the distance between the two balloons, we concluded that when the balloons are farther apart, they have a greater kinetic energy and a lower electric potential. And this is vice versa for if the distance between the two balloons is closer. So if it's closer, that's going to result in a stronger force between the two balloons. However, we got to take this with a grain of salt. Although we determined that an increase in distance will lead to a weaker force between the two balloons, we can't determine exact charges just from one experimental trial, meaning we can't extrapolate that data to where we can say that if the charges are 0.5 meters apart, it's going to equal this exact charge. In order to do that, we'd really have to dive a little bit deeper into our experiment and work a little bit more and do a lot more trials to do that. Thank you. I hope you enjoyed our experiment. Have a great day.